Hey everybody, just gonna get Thursday's lesson up here, and it's on factoring and expanding different patterns. And so in this one, what you're gonna commonly notice is there's a couple different patterns. So this one we are squaring this term here, and I did a whole warm-up lesson on what is a square and what are the different squares, and this one is also squared. So if I'm gonna expand this, these are kind of a bit of patterning. So what you can do next, and you can kind of skip this first step. I will take the second and write it out. So if I say something's squared, that means it's being times by itself. So if I have something that's being squared, it's being multiplied by itself, and the operation that's right in there is multiply. So the next thing I do is I think about what's x times x. I know that's x squared, and then I know that I go x times positive 4 to get positive 4x. And next I do positive 4 times x, which is positive 4x. Plus 16. After I've expanded, now I simplify to get x squared plus 8x plus 16. So there's a pattern that we're looking for, and I'll just expand this one too to kind of help illustrate the pattern. And again, you don't have to write this first step, but it is helpful for some just to visualize what they're going to do. And again, I'll expand. So what's 2 times 2? It's 4. And what's x times x? X squared. Next I go, what's 2 times negative 5? And 2 times negative 5 would be negative 10x. I do that again, what's negative 5 times 2x to get negative 10x. And then finally I know that negative 5 times negative 5 is positive 25. My pen doesn't want to write on the side like that. Next I simplify, so 4x squared minus 20x, because I know that negative 10 minus 10 would be negative 20, plus 25. So what is the pattern? And that's the important question that this all comes down to. And when you start to recognize the pattern, you can start to move forward very quickly. So if I've got two numbers, let's call them p and q. I've got p plus q squared. You can skip all the way to the following answer. You can take p and square it. So p squared, and then you multiply p and q together, and then you multiply by 2. So then you would say 2pq, and then finally you take the last term and square it, q squared. So if this doesn't make any sense to you, and you look at that pattern and you're like, I have no idea what he's talking about. Let's look at this example. What is x squared? Sorry, what's x to the power 2? It's x to the power 2. Now I take the first term and multiply it by the second term. So what's x times 4? 4x. And then I multiply 4x times 2 to get 8x. And I square the last term, 16. And because it's a positive, my two signs are positive. In this one, I'm going to apply the trick again. So first we square 2x to get 4x squared. Then I take 2x and multiply it by negative 5 to get negative 10. Negative 10 times 2 is negative 20x. Sorry, I should have said 2x times negative 5 makes 10x. Negative 10x times 2 is negative 20x. And then finally I go negative 5 squared makes positive 25. And so you are allowed technically to skip from here to here if you are recognizing this pattern to help you save time. And you can skip like that. So when you're asked to factor, sometimes it's helpful to look at the very, very first term and the last term and think about if they're perfect squares. If the first term or the last term are perfect squares, there's a shortcut you can do. But first I'll take a second and I'll do the math to kind of explain what's going on and what the shortcut is that you can use. So the first thing I'm going to do is I'll go ahead and I'll make a t-chart. So when I do that, I should make sure my pen's on. So to make my t-chart, I'm going to do like we've done in the past. I know I need to add to 20, and so I need to multiply. Don't forget that you need to multiply these two terms together. So I need to multiply those two together to get positive 100. Okay, good. So now you got to think to yourself, what multiplies to 100 and adds to 20? And I know because it's a perfect square that it's 10 and 10, both positive. So now I'm going to decompose this number, and so that's going to give me with 25b squared plus 10b, pen's kind of acting up, plus 10b plus 4. So the next thing I'm going to do is I'm going to look for some common factors, and I know in here a common factor in these two terms is 5b, and I can look at these two terms and look at them and think that a common term would be, or a common factor would be positive 2. So factor those out, and I'll think to myself, what's 25 divided by 5 after I've factored it out? And I know that 25b squared divided by 5b is 5b. And I also know that 10 divided by 5 is 2, and the b's will cancel out. Alright, plus 2 right here, and I'll do the same math. So 10 divided by 2 is 5 with the b left over, and 4 divided by 2 is 2. So now I'll divide out the common factor of 5b plus 2 and 5b plus 2, and I'll get the answer of 5b plus 2 times 5b plus 2, which you can also think of, and I'll just write it here, as 5b squared. So what's the pattern here? Well, when you see a perfect square, so if you see that the first term and the last term are perfect squares, and you can't divide out a common term amongst these, so I can't divide out 2 or 4 or 3 out of these terms, what I end up doing is you can just look at the first term, and so if you've got a p squared plus 2pq plus q squared, you can just look at these terms, and what you can do is you can take the root of p squared and the root of q squared, and you can kind of ignore the middle term. And then what you can write for your answer with quick factoring is you take these terms and you would write p plus q squared. So just to show you, that p would go there, that q would go there. So let's apply this real quick, and we'll do the shortcut. So the shortcut, I'll square those two to get my factors, and I know that it'll be 2 terms squared. So what I do is I say, well, what is 25b squared? What are my factors if I use the square root of that? So I kind of say, all right, that's 5b because it's a b squared. And the next one I do is I take the square root of positive 4, which is positive 2. And there's the shortcut done. So, and you can go directly from here straight to your factored form with that shortcut. So now, when you look at this, you have to look at a couple things. So first, this looks like a perfect square, and this looks like a perfect square. So you already know that you're looking at a special case. The second thing here that's different now is now you've got a difference or a subtraction sign. So this is a difference of 2 squares, hence the title difference of squares. So another, like if we're going to take this and do a plus times chart, you know you're going to have to multiply to make negative 9. But I also find it helpful to think of this as x squared plus 0x minus 9, where we didn't have a 0x term. So now what you got to do is you got to think of a term that adds to 0 and multiplies to negative 9. I know positive 3 and negative 3 will do this because it's also the roots of 9. So next thing I do is I'll decompose 0 to be x squared plus 3x minus 3x, and yes, because of the mess, I'm just going to erase this because I don't need it anymore. So I'll just erase that brainstorming away because I know I don't need it anymore. Minus 9. Yikes. Sorry about that. I'm going to do my equal signs here. So the next thing I'll do is I'll look for some common factors, and what I'll do is I'll say, okay, well, a common factor of these two here is x, and a common factor of these two here is negative 3. I'll go x bracket x plus 3, 183, x plus 3, and I'll factor out the common factor, so I'll get x plus 3 factored out, and then I'll look here and say, okay, what's left over, and I know that I've got x minus 3 left over. This is a really long way of doing it, and even back when you did your plus times chart, and you had 9 and 0, and you actually got negative 3 and 3, you'll remember from the start of this unit, I allowed you to go from here directly to the answer that you got here. So that's allowed. There's also a way that you can jump directly from what I give you in the factored form. So you're allowed to, if you recognize this pattern, you're allowed to jump from here directly right down to our answer there. So the pattern typically goes like this. That you have a x squared, or sorry, not an x squared. I'm going to just take 1 second and just delete that. There we go. So if you have a p squared minus q squared, and the big key to these questions is that you've got the minus sign, so it's the difference of squares. What you do for your answers, you go like this, and you take the root of your 2. Once you figure out the root of p and q, your answer is going to be p minus q, p plus q. And so what I'm going to do is I'll make a prediction. And so what I'll do is I'll recognize that this is a difference of squares question. And what I'll do to start is I'll just say, okay, I think that my answer is going to be x minus 5 and x plus 5, because I recognize that these are both squares. And you're allowed to do that. If you do it the other way, then you'd say x squared, and I'll just draw a little bit of a boundary line between that and our last question. And now we're going to add our 0x and minus 25. I'll do my plus times chart, and I know I need to multiply to negative 25, add to 0, and I know these factors that will do that will be positive 5 and negative 5. And that actually can be plugged in right there as x minus 5. I just got to get the eraser out and just erase that just to give myself a little bit more room. Just give me a second, honey. I'm just going to finish this. And then x plus 5. And you're very allowed to go directly from these two factors to this answer. And you'll notice it matches our prediction perfectly. Finally, I did this one in class and people got really angry at me, but it's because people weren't thinking. When you look at this one to start, before you make any predictions or do this, you need to think, is there a greatest common factor between these two terms? And I know that there's a greatest common factor of 4. So I'm going to factor 4 out of this. So I'm going to take this and divide it all by 4, each one of these by 4. So I factor out 4. I'm going to need a little bit more room here. I'm going to factor out 4, and I'm going to get x squared minus 4. Now we are going to reevaluate and rethink. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. And is this a difference question? Yes, it is. So you're allowed to jump right to your final answer. And so I'm going to rewrite my factor that I took out. And because I know the pattern, it's going to be x minus 2. And I've run out of room again. X plus, I can't even write it in. I'm trying to write plus. I can't write it in. Just give me a second. So it'll be 4x minus 2, x plus 2. Sorry, I can't even get my stylus to register on the edge there, but there you go, factoring the difference of squares example.